Today we are talking about multiplying and dividing monomials. And monomial is a number, a variable, or a product of a number and variable. Okay, and variable. Okay, so an example of those would be 8. A variable would be a, and a product of a number and a variable might be 8a. Okay, so these are examples of monomials. Okay, so and they can also have exponents. So 8a squared would also be a monomial. Okay, so we're going to take a look at what happens when we are multiplying and dividing these types of numbers, specifically with the exponents involved. So we can see here in this first one, 9 to the third power times 9. Okay, if I broke this 9 cubed apart, I would have 9 times 9 times 9 times 9, right? Well, this is the same thing as 9 to the fourth power. Recognize I have an imaginary 1 as my exponent here. What's happening to these two exponents here, the 3 and the 1? Well, if you add them together, you get 4. Your base stays the same. 3 plus 1 is 4. Let's check and see if that same process works on the next one. So 3 to the second power, again, if I write it out, 3 times 3, that's my 3 squared, and then 3 times 3 times 3, that's my 3 cubed. Well, I could rewrite this as 3 to the fifth power. Okay, 2 plus 3 is 5. 3 to the fifth power. It works there as well. Okay, so we can utilize that same thing even when we have a variable as our base. Again, base stays the same. Add my exponents. 6 plus 2 is 8. Okay, m is my base. 10 is my exponent, and remember, if there is no exponent, it's an imaginary 1. So I have m to the 11th power. Don't forget to add that 1 though, because m to the 10th would not be the correct solution there. Okay. Now, if we take a look at 5 and 6, there are lots more things happening here, but we can separate all this out and uh, and in 5 and 6, we have a lot more happening, but we can break apart these and group them by common variables or constants. Okay, not constants, coefficients. Okay, so we have 2 times p squared times q to the fifth power times 7 times p times q. Okay, so you can see q to the fifth and q to the first. We can group those, and that would give me q to the sixth power. I also have this 2 and this 7, and we can go ahead and just multiply those like normal. 2 times 7 would be 14. I'm going to put that in front as my coefficient. And then I've got p's. Okay, p squared and p. So that's going to give me p to the third power. And when we list our variables, typically we go in alphabetical order. So the proper way of writing this would be 14 p to the third power, q to the sixth power, because p comes before q in the alphabet. Okay. I'll let you go ahead and try number 6 on your own there with that example from number 5, and we're going to come down to number 7 here. Same thing is true here, but we've got that negative situation here, so we're including negative. Now, m is to the fifth power. Only the m is to the fifth, not the negative 2. Okay, if the 5 was on the outside of the parentheses, then it would go to both. Okay, so for this one we have 6 times m to the fourth power times -2 times m to the fifth power. Again, 6 times -2 gives me -12. M to the fourth, m to the fifth. We add 4 plus 5 gives me m to the ninth power. Okay. Okay. Then we're going to come down and take a look. So that's multiplication, multiplying our monomials. If we're dividing monomials, we're going to do the opposite operation. So here we can see a to the 10th divided by a to the 5th. Okay, if I list all these out, a times a. Okay, on number 9, we have some division here. So a to the 10th power divided by a to the 5th power. So again, I'm going to write these out to show you what's happening here. Then a divided by a would be the same thing as 7 divided by 7. So you get 1 anytime you multiply something by itself. So we can kind of cancel out these. Okay, and we're going to cancel out 5 of them because there's 5 on top and 5 on bottom, which leaves a to the 5th power on top. So we have a to the 5th over 1 minus 1/3 here. Okay, so this is our answer simplified. Okay, same thing here. So basically 10 minus 5 is 5. So here we can do the same thing. H to the 16th, h to the 10th, so 16 minus 10. So h and then 16 minus 10 equals 6. So h to the 6th power. Okay. All right, and you can see down here at the bottom, we have several combinations of some division problems, and you can break this apart into 3 separate problems here, okay? 2 to the 3rd power divided by 2 to the 2nd power, 3 minus 2 is 1, so we have 2. 5 to the 6th minus, divided by 5 to the 3rd power, 6 minus 3 is 3, so 5 to the 3rd power. And then 9 to the 5th divided by 9 to the 2nd, so 5 minus 2 is again 3. Okay, so recap. When you are multiplying monomials, you keep the base the same and you add your exponents. When you are dividing monomials, you keep the base the same and you subtract your exponents.